Check that the oil tank cap, figure 51, is correctly tightened and the valve cap, figure 73, is correctly blocked in its seat before supplying the machine with the compressed air. All the components of the riveting tool should be cleaned with proper detergents before being assembled again. Supply the machine with the pressure from 6 to 7 bar, then increase it progressively up to more than 8 bar to check the overpressure valve startup, figure 103. Stop the compressed air supply. Unscrew the tank cap, figure 51, with an Allen spanner of 4 mm and remove it together with the seal washer, figure 50. Protect the oil inlet hole for preventing accidental leakage, then connect the supply of compressed air with the pressure from 6 to 7 bar and drain the oil completely using the control push button more times. For the following disposal of the used oil, follow the International Safety Environmental Standards for the disposal of used oils. Cut off the compressed air supply. Remove the service push button, figure 52. With an Allen spanner of 3 mm, unscrew the screw, figure 48, and remove the fender motor, figure 49. Using the Allen spanner of 2.5 mm, unscrew and remove the screws, figure 54, and disassemble the silencer, kit E. Remove the gasket O-ring, figure 58, then remove the rod, kit F, and the pertaining gasket O-ring. With an Allen spanner of 2.5 mm, unscrew and remove the 2 screws, figure 57. Lift and extract the air connector, figure 55, then remove the 2 gaskets O-ring, figure 56. Using 2 commercial spanners of 26 and 32 mm, unblock the valve unit for motor control, figure 40, then unscrew it slowly until its complete extraction together with the motor, figure 39. Extract the motor, figure 39, from the valve for motor control, figure 40. Then check its condition. In particular, the internal valve should be sound and free to move without problems. Check the condition of the threads, that the dowels present on the part are not loosened, and the good condition of all the seats. Disassemble the motor, figure 39, removing the crown gear, figure 1, planetary gears and gears cage, figure 2, 3 and 4, connector, figure 5, bearing, figure 6, external body, figure 8, and a rotor, figure 11, with its tongues, figure 10. After having cleaned the parts with proper detergents, assemble them again, checking first of all that the rotor, figure 11, rotates freely. Otherwise, replace the pertaining bearing, figure 13. Check the condition of the front cap, figure 7, and its bearing, figure 6, replacing the worn parts. Check the condition of the central planetary gear, figure 4, removing it from its connector, figure 5. If it is worn, replace it. The central planetary gear can be assembled on the front or back part of the connector. Check the condition of the 5 tongues, figure 10. If they are worn, replace them all. Check the condition of the crown gear, figure 1. In particular, the teeth should be not damaged, otherwise replace the part. Check the condition of the 4 planetary gears, figure 3. If they are worn, replace them all. Check that the outer body, figure 8, has not scorings inside. Be sure that the pin, figure 9, is sound and well fastened on the part. Check the perfect condition of the gear cage, figure 2, controlling that the pins are still and have not suffered damages. Assemble the 5 tongues, figure 10, on the rotor, figure 11, introducing them from the curve part so that they are on the line in their seat. Assemble the external body, figure 8, on the back cap, figure 12, introducing the pin, figure 9, into the central hole. Join the 2 parts so that the pin comes out correctly. Assemble the front cap, figure 7, on the rotor, figure 11. Checking the shaft position, introduce the planetary gear, figure 4. Introduce the saw-formed unit on the valve unit for motor control, figure 40, putting the pin, figure 9, into the proper hole. Complete the motor assembly introducing the pertaining gears, figure 3, into the pins of the gear case, figure 2. Grease the assembled parts with Berylite GA400 grease, then engage the planetary gears, figure 3, with the central planetary gear, figure 4, checking the rotation. In the end, clamp the crown gear, figure 1, engaging it with the planetary gears, figure 3. Check the silencer components, kit E. If they are worn and inefficient, replace them completely. With a spanner of 22 mm, loosen the ring nut, figure 47. Then remove it with its head, figure from 1 to 18. Always with a spanner of 22 mm, unblock the tube, figure 46. Then unscrew it for its complete removal. With the 2 spanners of 20 mm, unblock the tie rod, figure 45. Then unscrew it and remove it with the tie rod, figure from 2 to 20. Extract the hexagonal reduction, figure from 3 to 21. Then the driving shaft, figure 44, with the spring for tie rod, figure 43. With the spanner of 26 mm and one of 20 mm, unblock the reduction, figure 42, then unscrew it for its complete removal. With the same spanners, unblock the nut, figure 41, then unscrew it for its complete removal. Unscrew and remove the ring nut, figure 36, with a face spanner. Check the condition of the internal O-ring, figure 38, and the external one, figure 37. If they're worn, replace them. Using a rubber hammer, hit the front part of the oil dynamic unit coming out from the back part of the cylinder, kit C. Then extract the jacket, figure 28, from the oil dynamic piston, figure 33. Check the roughness of the oil dynamic piston stem, figure 33, which should be of 0.2 Ra, and that the threads are in good condition. Control that there are no cracks or breaks on the parts too. Disassemble the gaskets. Extract the balselle, figure 34, the pertaining anti-extrusion ring. In the end, the gasket O-ring, figure 35. Important: in case of machine overhaul, replace the gaskets. Taking care that the beveled part of the anti-extrusion ring is turned upwards. Put it into the oil dynamic piston, figure 33. Using a special tool deliverable on demand, previously grease with the grease polymer 400/2, assemble the balselle, figure 34, being sure that the sealing lip is turned upwards. In the end, introduce the basket O-ring, figure 35, into its seat. Remove the gasket, figure 32, from the front part of the jacket, figure 28. Remove the flange, figure 29, using an extractor. Check the condition of the gasket O-ring, figure 31, and its ring per back, figure 30. In case of machine overhaul, replace them. Check the soundness of the jacket, figure 28, in particular that there are not scorings inside and that all the seats of the gaskets are in good condition. Grease the oil dynamic piston previously assembled. Then introduce it into the jacket with a hammer with the rubber end, figure 28. Apply grease polymer 400/2 on the flange, figure 29, then assemble it on the jacket, figure 28. In the end, introduce the gasket O-ring, figure 32, into its seat. Block the riveting tool in a proper vise, then remove the protection bottom, figure 98. With a special tightening spanner, deliverable on demand, disassemble the cover, figure 87. Remove the gasket O-ring, figure 100. Extract the pneumatic piston unit. Remove the pneumatic jacket, kit O. Keeping the oil dynamic cylinder pushed upwards, unscrew the guide stem connector, figure 79, with a proper spanner deliverable on demand. Now the oil dynamic cylinder, kit C, and the handle, kit M, will be released. Extract the guide stem connector, figure 79. Check the gasket O-ring, figure 100, and if necessary, replace it. With a cross-point screwdriver, unscrew and remove the 4 screws, figure 92. Using an Allen spanner of 3 mm, unscrew and remove the central screw, figure 91. Now the knob can be removed, figure 88. Lower the screw, figure 95, then disassemble the outer gasket O-ring, figure 75. With the face spanner, remove the ring nut, figure 89. Then disassemble the disc, figure 90, and the ball, figure 72, checking that the old parts are in good conditions. Using a pin, remove the spring, figure 97, from the cover, figure 87. Release the flanged connector, figure 93, from the cover, figure 87, extract the driving shaft, figure 94, checking its condition, the condition of the gasket O-ring, figure 70, and the screw, figure 96, replacing the worn parts. With an Allen spanner of 8 mm, disassemble the double thread screw, figure 95. Apply grease polymer 400/2 on the driving shaft, figure 94, and introduce it into the double thread screw, figure 95, through the circular hole. Screw the sulform unit on the flanged connector, figure 93, which should be fitted on the cover, figure 87, introducing the slot into its seat. Put the spring, figure 97, on the cover, figure 87. Place the ball, figure 72, on the spring. Assemble the disc, figure 19, so that the hollow matches on the ball, figure 72, after having greased the part. Screw the ring nut, figure 89, blocking it with the face spanner. Introduce the gasket O-ring, figure 75, on the ring nut, figure 89. Assemble the knob, figure 88, on the driving shaft, figure 94, taking care that the hexagon matches. Then tighten the screw, figure 91, blocking it with a spanner of 3 mm. Rotate slightly the knob, figure 88, up to the center of the holes, then assemble the 4 screws, figure 92, using a cross-point screwdriver. Carry out some test drives to be sure that the knob, figure 88, works properly. Complete the assembly of the cover, figure 87, introducing the gasket O-ring, figure 100, into its seat. Check that a pneumatic piston stem surface, figure 86, has not scorings and that its roughness is 0.2 array. Check the condition of the gasket O-ring, figure 102. In case of machine overhaul, it is advisable to replace it. Check the condition of the gasket O-ring, figure 101. In case of machine overhaul, it is advisable to replace it. Check that the nut, figure 84, is correctly tightened, applying Loctite number 542. Reassemble the external gasket O-ring, figure 101, and the internal one, figure 102. Check that the pneumatic jacket, kit O, has not scoring inside. It is not out of round, and the external foam is sound. Extract the gasket O-ring, figure 82, from the guide stem connector, figure 79. Remove the gasket O-ring, figure 83, from the guide stem connector, figure 79. Then remove the gasket balselle, figure 81. In the end, remove the gasket, figure 80. Important: in case of machine overhaul, replace the gaskets. Assemble the gasket again, figure 80, being sure that the seal lip is turned upwards. Use the same procedure for the balselle, figure 81. Assemble the gasket O-ring, figure 83, housing it in its own seat. In the end, assemble the gasket O-ring, figure 82. Check that the parts consisting of the aerodynamic cylinder, kit C, are well fastened and integral one another, and that they are not worn. Check the condition of their seat, threads and gasket. Be sure of the internal conditions of the cylinder. In particular, the threading should be in very good condition. Extract the figure ring, figure 27, using proper pliers. Using an extractor, remove the balselle, figure 27, and replace it. Check that the white ring is directed inwards and assemble the new balselle. Figure 26. Assemble the figure, figure 27, again. Be sure that it is correctly placed in its own seat. Check the body, figure 71. In particular, the condition of the pipe, which should not be doubled, and that there is a bush close to it. Remove the gasket O-ring, figure 100, and check that there are no cracks or breaks on the body, figure 71. Using an outlet spanner of 6 mm, unscrew and remove the valve cap, figure 73. Using an extractor, remove the coil, kit P, completely. Check all the components, replacing the worn parts. Important: in case of machine overhaul, replace the gaskets. In particular, check the conditions of the coil, figure 74, which should have no defects or scorings. Check the perfect conditions of the valve cap seat, in particular the soundness of the threads. The components of the coil unit, kit P, 6 O-rings and 5 casings, should be assembled alternatively on a proper spanner deliverable on demand. Apply grease Reolube 362 HB on the components of the coil unit. Introduce the cap into the seat of the valve, taking care of the introduction side, pushing it completely with a special spanner prepared previously. Remove only the back part of the special spanner to keep the parts of the valve. Check the right housing of all parts in their seats. Introduce the spring into the coil, figure 74. Then apply the grease Reolube 362 HB and introduce the two parts into the valve seat. Check the good condition of the seat, threads and hexagon of the valve cap, figure 73. Then apply Loctite 542 on it. In the end, screw it with an Allen spanner of 6 mm. After having replaced it, introduce the gasket O-ring, figure 100, into its seat. Then introduce the pneumatic jacket, kit O, placing it in correspondence of the seat of the gasket O-ring previously assembled. Remove the gasket's O-ring, figure 63, from the handle, kit M. Figure 62 and figure 61. Important: in case of machine overhaul, replace the gaskets. Using a pin punch, remove the roller. Figure 65. Now the push button unit can be removed, figure 67. After having removed the pertaining screws, disassemble the retaining plate, kit L. Remove the gasket O-ring, figure 64. Using an extractor, remove the upper piston, kit H. With pliers, remove the lower piston, kit I. Check the soundness of all components of the upper piston, kit H. In particular, all the gaskets O-ring, which should be replaced in case of machine overhaul. The same operations will be carried out with the lower piston, kit I. In particular, if the internal piston is disassembled, they should be assembled again in its seat on the side with the less strong bevel. The bigger bevel should be on the exit side of the piston itself. After having greased with polymer 400/2 and checked the right working, reassemble the upper piston, kit H, in its own seat. Repeat the same operations for the lower piston, kit I. Introduce into its seat the gasket O-ring, figure 64, previously replaced, and apply grease polymer 400/2. Reassemble the retaining plate, kit L, and block it with the pertaining screws. Check the right working of the internal components of the push-button unit, figure 67, with a compressed air jet. In case of problems, replace the part. Assemble the push-button unit, figure 67, on the handle, kit N, pressing slightly up to a locking snap. Then complete the assembly introducing the roller, figure 65. Apply grease polymer 400/2 on the handle, kit M. Then introduce the two gaskets O-rings, figure 63, into their seats. Then the gasket O-ring, figure 62. At last, put the gasket O-ring, figure 61, on the upper part. Apply greased polymer 400/2 in the oil dynamic cylinder, kit C, and on the piston shaft, figure 33, whose thread will be previously protected with a single turn of proper adhesive tape. Taking special care of the thread, introduce the piston, figure 33, carefully into the oil dynamic cylinder, kit C. Screw the ring nut, figure 36, blocking it completely with the face spanner. Remove the temporary protection previously placed on the front thread of the piston, figure 33. Then apply Loctite number 270 on the back thread. Introduce the previously assembled unit into the oil dynamic cylinder, consisted of the motor, figure 39, and the valve unit for control motor, figure 40, and screw it completely. Then block it using two spanners of 26 mm and 32 mm. Assemble the handle, kit M, on the oil dynamic cylinder, kit C, pressing slightly up to a blocking snap. Assemble the two gaskets O-ring, figure 56, on the air connector, figure 55. Introduce air connector pipes, figure 55, on the handle, kit M. Then assemble the air connector, placing it in its own seat. Tighten the two screws, figure 57, blocking them with an Allen spanner of 2.5 mm. Block the body, figure 71, in a proper vise. Apply grease polymer 400/2 on the guide stem connector, figure 79. Join the handle unit, previously assembled, to the riveting body. Introduce the guide stem connector, figure 79, into its seat, then block it screwing with the special spanner available on demand. Apply grease polymer 400/2 on the pneumatic piston, its stem and jacket, then introduce it into the riveting body. Close the riveting body screwing the cover, figure 87, using a special spanner deliverable on demand. Assemble the protection bottom, figure 98. Assemble the kit F, consisting of the gasket O-ring and its rod. Introduce the gasket O-ring, figure 58. Assemble the silencer, kit E, then fasten it with its screws, figure 54, using an Allen spanner of 2.5 mm. Assemble the fender motor, figure 49, pushing it completely, then tighten the screw, figure 48, using an Allen spanner of 3 mm. Introduce the service push button into its seat. Screw the nut, figure 41, on the pneumatic piston, figure 33, taking care that the distance between the nut and the oil dynamic cylinder is about 6.5–6.7 mm. Apply Loctite number 270 on the thread. Then screw the reduction, figure 42, on it, blocking it with the two spanners of 20 mm. Introduce the driving shaft, figure 44, with the spring for tie rod, figure 43, into its seat. Apply grease Berylite GA400 on the tie rod, figure from 2 to 20, then introduce it into the tie rod ring nut, figure 45. Introduce the hexagonal reduction, figure from 3 to 21, into its seat. Assemble this unit, screwing the tie rod ring nut, figure 45, on the reduction, figure 42. Then block it with the two spanners of 20 mm. Screw the tube, figure 46, on the oil hydraulic piston, kit C, blocking it with a spanner of 22 mm. Screw the ring nut, figure 47, with its head, figure from 1 to 18, on the tube, figure 46. Bring the ring nut to the maximum opening position, rotating it in the direction indicated by the symbol plus. Then rotate it in the direction of the symbol minus to find the first available position. Supply the riveting tool with a pressure from 6 to 7 bar. Screw the bellows oil container, figure 24, supplied in the cab seat. Press the control push button so that the riveting tool carries out a series of cycles until the emission of air bubbles in the bellows container, figure 24, stops completely. This condition means that the oil filling in the cylinder is complete. Now unscrew the bellows oil container and close it. Replace the seal washer, figure 50, and close the cap, figure 51, with a torque of 5 Newton meters. Tilt the riveting tool and make it carry out a new series of cycles. Remove the cap again, figure 51. Check the oil level and fill up until the whole edge is reached. Close the cap definitely, figure 51, with a torque of 5 Newton meters. Press the control push button so that the riveting tool carries out a series of cycles to check if the stroke is carried out correctly. This condition can be checked with the graduated scale placed on the fender motor, figure 49. Adjust the stroke according to the dimensions of the insert to be tightened. Cut off air supply. According to the dimensions of the insert and thickness of the material to be clamped, use the knob, figure 88. See the diagram of the instructions for use of the riveting tool. Checking the changes with the graded scale placed on the fender motor, figure 49. Supply the riveting tool with a pressure from 6 to 7 bar. Press the control push button so that the riveting tool carries out a series of cycles. Adjust the tie rod hair pair following the indications in the instructions for use of the riveting tool. Block definitely the head, tighten completely the head ring nut, figure 47, with a spanner of 22 mm. Introduce the insert on the tie rod and press slightly so that it is screwed automatically on the tie rod. Verify that the head of the insert goes against the riveting tool head and the tie rod comes about 2 mm out of the insert. Carry out some cycles to check the right working of the machine and finish the adjustment of the stroke according to the tightening of the insert on the material. Bear in mind that an incorrect adjustment of the stroke can cause the bad tightening of the inserts and breaking of the tie rod.
With a spanner of 22 mm, unblock the tube, figure 46, then unscrew it for its complete removal. Remove the tie rod, figures from 2 to 20. Then extract the hexagonal unit, figures from 3 to 21. With a spanner of 20 mm and another of 23 mm, unblock the cone carrying tie rods, figure 44, then unscrew it until a complete removal. Extract the driving unit, figure 42. After that, remove the spring, figure 43. Check the condition of the driving unit, figure 42. If it is malfunctioning, replace it. Unscrew and extract the nut, figure 41, and check if the threads are in good condition. After having checked that all components are in good condition, and after having replaced the worn parts, assemble them again. Screw first the nut, figure 41. Introduce the spring, figure 43, onto the driving unit, figure 42. Then, put this one in its seat onto the cone carrying tie rods, figure 44. Screw the so formed unit on the oil dynamic piston, applying Loctite number 270. Take care that, once the cone carrying tie rods is positioned, the vertical misalignment of the slot does not exceed 10 degrees. Then, with a spanner of 20 mm, having a thickness of 7 mm, used as spacer, keep the nut, figure 41, blocked. At the same time, tighten the cone carrying tie rods, figure 44, by means of a spanner of 23 mm. Check if the movement of the driving unit, figure 42, is correct. Introduce the hexagonal unit onto the tie rod, checking that the magnet works and is in good condition. Assemble the components, making sure that the parts are correctly in their seats by turning the tie rod manually. Screw the tube, figure 46, with ring nut and head, onto the oil dynamic piston. Block it by a spanner of 22 mm. Supply the riveting tool with a pressure from 6 to 7 bar, then carry out a series of cycles, and perform all the adjustments on the pair, composed of tie rod and head, as shown for model KJ45. Extract the C-ring, figure 99, using proper pliers. Then, extract the overpressure valve unit, figure 103. Unscrew the ring nut, figure 104, then tighten the overpressure valve unit, figure 103, in a vise. By using a spanner of 15 mm, disassemble the valve unit, and extract the cursor. Remove both O-ring gaskets, figure 106, and check if the two seats are in good condition. It's very important to replace the O-ring gaskets, in case of machine overhaul. Then fit both O-ring gaskets, figure 106, in their seats again. Apply grease of type Polymer 400/2 inside the cursor, then assemble it on the valve unit. apply Loctite number 542 on the thread of the overpressure valve unit, and complete its assembling. Screw the ring nut, figure 104, then check that the cursor slides properly on the valve. Introducing from the side, where the bore has the larger diameter, assemble the overpressure valve unit, figure 103, on the air connector, figure 76. By means of a proper pliers, assemble the C-ring, figure 99, in the relevant seat. Finally, supply the riveting tool with a pressure from 6 to 7 bar, then carry out a series of cycles, in order to verify if the overpressure valve unit works correctly.